Each time a new vendor wants access to your systems, someone on your security team has to manually review a SOC 2 report, questionnaire, and a contract, then write up a risk assessment all from scratch. It's tedious, takes hours, and honestly, it's exactly the kind of structured, repeatable work that could be automated. So, we built a small app that accomplishes that workflow using Box and LangChain's Deep Agents SDK. You put it in a Box folder full of vendor documents, run one command, and it writes a complete risk report back to that same folder, with metadata on every source file and a human review task waiting for your security team. I'm Andrew, Senior Developer Relations Engineer here at Box. Let's check it out. Here in the example app, let's check out the architecture. Documents come in from a Box folder. Box AI extracts structured data from those files. That gets loaded into an in-memory virtual file system. And then a LangChain Deep Agent takes over. It spawns 3 parallel subagents, one each for security, compliance, and contract risk. Then each subagent reads from the shared file system, writes its findings back, and the orchestrator synthesizes everything into a report that gets published back to Box. Deep Agents is LangChain's agent harness built on LangGraph. The key thing to note is that it adds subagent spawning with isolated context windows and that pluggable virtual file system, which is the sandbox, so to speak. It's all in memory, no containers, and it makes more sense once you see it in code, so let's check it out. Here in our editor, I actually want to start with the output side, because I think it's the most useful part to understand first. Over in our publish results function, after the agent finishes, this function is going to make 5 Box API calls in sequence. First, create a subfolder, upload the report, tag metadata on it, generate a shared link, create a review task, then loop back and write that same metadata onto every source file in the original folder. So, for example, when your security team opens a vendor folder in Box, the contract PDF will have the risk level tagged onto it, as well as a direct link to the report. This way, they have context before they've even opened a single document. Next, along with the output that we just saw, let's now take a look at the input side. For the files we're using Box AI extract structured on, the way it works is that you define a field schema. So here's the one for the SOC 2 report. Then, over in our client, we have the actual API call itself. We have the file ID, your field schema, and you get back typed JSON. There's no need to hook up your own OCR, no custom PDF parser, no embedding pipeline. Box AI reads the document and gives you exactly the fields you asked for. For other documents, like the questionnaire, we actually use Box AI Ask instead. And that one works better as a freeform prompt, since the answers don't necessarily map cleanly to a fixed schema. At this point, once Box AI has turned our documents into structured JSON, we load all of it into the VFS sandbox. In short, each document becomes a file at a predictable path. The reason we do this, rather than, say, dumping raw text into the prompt, is context management. The agent reads structured summaries instead of full PDF content, which keeps things focused. Raw text is still available under /raw if a subagent needs to verify something specific. Otherwise, subagents write their findings back to /findings, and when the run finishes, we read those files out to build the report. To wrap it all up and see how everything's wired, let's check out the agent setup here. The subagents array is where the 3 specialists get registered. Each one has a name, a description, and its own system prompt. The orchestrator dispatches all 3 in parallel, and each one gets an isolated context window. It then does its analysis against the VFS and writes findings back to /findings. Then, the orchestrator reads everything back and synthesizes a final risk score. And just to clarify, the entire orchestration logic lives in a prompt. There's no custom graph code nor any extra wiring. Create Deep Agent is what handles the loop. All right, now that we've seen the code, let's check out the files we're going to run this on. Back in Box, this is the Globex Data Solutions folder. It's a fictional high-risk vendor from the sample set, and it includes a SOC 2 audit report, security questionnaire, an MSA, and a company profile, all in different unstructured formats. Let's run the app and check it out. In our terminal, we'll run this command, and it'll be scoped to the files that we saw in that folder, hence the ID that we're giving it. We'll submit this. Now, you can watch the steps tick through, authenticating with Box via CCG, listing the folder, processing each file through Box AI, building the sandbox, initializing the model, and then kicking off the Deep Agent. The agent run itself might actually take a couple moments, so we'll just fast forward ahead. And there's the output. Globex scores 68 out of 100, high risk, and the recommendation is to escalate. On top of that, we also have the share report link right there at the bottom. Let's take a look. In our risk reports folder, we have the risk report the agent automatically generated and published to Box. It opens in the Box Markdown editor with an executive summary and risk dashboard. Then it walks through each finding with a severity level, evidence, and recommendation, all structured and ready for a human reviewer. And of course, on the source files, pulling up the metadata on the SOC 2 report, we have a few details tagged back onto the file, such as the risk level, review date, and the assessment URL, which links it back to the report. So, a reviewer browsing this folder has a full picture before they even open a single document. So that's the full loop. Box AI does the document extraction on the way in, LangChain Deep Agents handles multi-agent reasoning in the middle, and Box closes the loop with the report, metadata, and collaboration on the way out. If you want to try it out yourself, check out the repo on GitHub. And if you haven't already, feel free to sign up for a free developer account. I'm Andrew. See you next time.